Hi everyone. In last video, we have seen half-wave rectifier and what are the types of rectifiers and how the half-wave rectifier works and what are the advantages, disadvantages of half-wave rectifiers. In this video, we are going to see about full-wave rectifiers in continuous of half-wave rectifier. In this video lecture series, we are going to see what is full-wave rectifier and what are the types of full-wave rectifier and how the full-wave rectifier works, etc. So first thing, what is full wave rectifier? Full wave rectifier, the rectification. Full wave rectification is the process current flows through the both the half cycle. Current flows both the half cycles. This can be achieved with two diodes working alternatively. And for one half cycle, one diode supplies the current to the load, and next half cycle, next diode supplies the current to the load. Here we are classified into two types. One is center tapped form, next one is bridged rectifier. So we have two type of connections. One is center tapped rectifier, next one is bridge type rectifier. Now first we are going to see what is center tapped rectifier. First thing. So this is what circuit connections of center tapped. Here we can see the AC power supply, and this is what center tapped transformer. We have three output connections, and we are using two diodes. We are using two diodes. For this, the usage of center tapped transformer is which splits the input waveform. Which splits the input waveform. So here the input waveform is 230-volt AC supply. Here the waveform is splits into two waveform. Here the waveform is split into two form. This is specialty of center tap transformers. Here now first, here the positive half cycle hits the anode, and the here in this the negative half cycles hits the anode. Here the diode D1 will be in on condition, and this diode D2 will be in off conditions. Now, in this diode D1 is in on condition, it acts as in forward bias, and the circuit will close like this, and we'll be getting one positive half cycles. And next thing is in next process, here this goes to positive half cycle, and this diode, the diode D2 will be in on condition, and this D1 goes to off condition next half cycle, and the current flows through D2, and finally we'll be getting another half conditions. So here we are the flow of waveform will be continuously positive half cycles. In previous half cycle, so only for one half cycle we are getting output. In this full wave rectifier, for both the half cycles we are getting the output. For both the half cycle we are getting the output. Here the currently the diode D1, D2 is center tap transformer. Here and next, so for one half cycle diode D1 is getting on, next half cycle is D2 is getting on. So everything we know that. Here the animation video, see the positive for positive half cycle diode D1 will be in on condition. For here negative half cycle the D2 will be in on condition, and you'll be getting another half cycle. So here you see the first positive half cycle, and here we have getting the negative half cycle. Here we can see the animation video of full wave rectifier. Here the instrument, this is when the reverse bias, what happens, which will be in this D2 will be in open circuit. Here the D1 will be open circuit. Okay, this is what the working animation of full wave rectifier. So here we have the during positive half cycle, D1 will be in conduction mode. Here the D2 will be in conduction mode. Here full wave rectifier. Here we can see the diode. In this is what bridged type. Here in bridge type we are using 4 diodes. So during period of interval, say for during positive half cycles, the diode D1. Here during positive half cycle, the diode D1. So the diode this and this diode gets on, and the current flows from positive load and negative. So next half cycle, see here we can see the complete animation video for first positive half cycle when the diode D1 and D2 gets on. How the current flows from positive load and negative. Here at that time the diode D3 and D4 goes to reverse condition and it acts as an open circuit, and D1 and D2 it is closed and it acts as a closed circuit. Here we can see the clear animation picture for forward. D1, D2 is in forward bias during positive half cycle. Next, the next process. So there is negative. Now the D3, D4 will be in closed circuit and D1 and D2 will be open circuit and will be getting next half cycle. We can see the next animation video here. Here when positive half cycle, what happens? It goes like this and overall full cycles. Finally, you'll be getting continuous half cycle. Finally, you'll be getting continuous half cycle, continuous cycles. So then since here the frequency, what happens? The output frequency for one forward full wave rectifier is equal to the double the input frequency. Here in previous cases, what happens in half wave rectifier? In half wave rectifier, frequency output is equal to frequency input. In previous half wave rectifier, But in full wave rectifier, what happens is the output frequency is equal to double the input frequency, double the input to FM. Here the output frequency. Okay. Here the small activity, the efficiency of full bridge rectifier is 81.2%. The overall efficiency of converting AC supply to pulsating DC supply is AC supply to pulsating DC supply is 81.2%. Here we have small animation video. So we all know about what are P-type semiconductors and N-type semiconductors. And that's what I explained in this video. Here the forward bias, what happens when it is in forward bias? What happens? In reverse bias, what happens? What happens in the depletion region? So the depletion layer gets increases. Here we can see the bridged type. In positive half cycle, the pass. In positive half cycle, it moves like this, and negatives. And finally, we are getting the output as a continuous pulsating DC. Here we are using capacitor and resistor. It stores the energy and is used for filtering purpose. Filters, and finally we are getting the DC output. I hope you understood what is rectifier and what is half wave rectifier and full wave rectifier. With another topic we can see in the next video. Thank you so much.